Trigonometry. Inverse functions of sine inverse, cos inverse and tan inverse. Sine and inverse sine are related functions, so that if sine theta is 5 over 13, we would say that theta is the inverse sine of 5 over 13. So 5 over 13 press inverse sine would give us theta. So if sine theta is 5 over 13, theta is the inverse sine of 5 over 13. Similarly for cos, if cos theta is 12 over 13, we would say that theta is the inverse cos of 12 over 13. And if tan theta is 5 over 12, we would say theta is the inverse tan of 5 over 12. Sine, written as sin, and inverse sine, written as sin to the minus 1, perform related or paired functions. They're twins. As each operator is the inverse of the other, the following relationships apply. So in the middle brackets here, we can see that we've got the sine inverse of theta. Outside that, we're taking the sine of the sine inverse. So we're performing one operator on another. And these are paired. The effect of this is that they cancel each other out. So the sine of the sine inverse gets rid of it, leaving you with theta equals theta. So to unlock a sine inverse, you multiply by sine. In this situation here, we've got sine theta in the middle, and we want to unlock that sine of theta. So if we take the inverse sine of it, we should be able to do so. The inverse sine of sine, they'll both cancel, and we'll be left with theta equals theta. And this applies for cosine and tangent as well. The cos of the cos inverse of theta is theta. Cos inverse of cos, theta is theta. Tan of tan inverse, theta is theta. And tan inverse of tan, theta is theta. So, in effect, these pairs lock and unlock the function. Let's consider an example. Find the angle theta here in the right angle triangle, knowing the lengths of the sides as follows. So we're given a triangle with sides 12, 5 and 13 and told it's a right angle triangle, and we're interested in this angle here. Well, starting with that angle here, knowing that it's a right angle triangle, it's useful to identify the opposite. So we've now identified the opposite side. And we know that the side of theta is opposite over hypotenuse. We found the opposite. The hypotenuse is going to be opposite the 90 degrees, and that gives us the adjacent as the third one. So sine is opposite over hypotenuse. In this case, knowing the opposite and hypotenuse, we get sine of theta is 5 over 13. So sine of theta is 5 over 13, but we're interested in theta. So the unlock function for sine is sine inverse. So we're going to take the sine inverse of the left-hand side, then we must also take the sine inverse of the right-hand side. So sine by sine theta will just give us theta. Sine inverse of 5 over 13, we can do this on a calculator. 5 over 13 in your calculator, press inverse sine, and you get 22.62 degrees. We've identified the angle. Similarly, we could find the angle using the cosine. Cosine theta in this case is k, so k toa. Cos adjacent over hypotenuse. So the cos of theta is 12 over 13. Cos theta is 12 over 13. If we know that, we can identify theta. The unlock key for a cos, or its pair, is cos inverse. The inverse cos of cos. On the left-hand side, we'll have to do the inverse cos of the right-hand side. These two will cancel, leaving theta equals the inverse cos of 12 over 13. On a calculator, 12 divided by 13, function inverse cos, gives us 22.62, the same as before. And we could have done this for tan as well. So with sine, we get 22.62, or for tan, opposite over adjacent, 5 over 12. Theta is the inverse tan of 5 over 12. Theta is 22.62.